Good evening, CSEC scholars. Welcome back to another live CSEC algebra class. Tonight we're going to be factorizing using the highest common factor. So there are a few ways in algebra that we can factorize depending on what we're given. The last algebra class that we did, I believe, we factorized using the distributive law. I think that's where we left off before we went for Christmas break. If we're factorizing quadratic expressions, there's another method we use. Tonight, we're going to be factorizing some relatively simple linear equations, and we're going to be using the highest common factor, pulling that out to the front, and then whatever is left back remains in the bracket. So I'll show you how that's done. Before we do that, I want you to take note of the schedule of our live PEP and CSEC classes. I'm going to run that by you right now. So write down these times and days. Math students, I know you are busy preparing for your math tests and your CSEC exams. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make, all the topics in CSEC math. We're going to look at the common errors, demystify everything, watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true. And we're going to be looking at the common errors that students make in the different, avoid making them. Are you ready? Come on, take my hand. Okay, she said, take her hand. So do that. We're going to go over now to the presentation and practice doing some factorizing. So what does it mean when we say that we're factorizing? And by the way, welcome Dinsmore. I did not see you in our PEP class. You know you're our regular customer, so you have to be present in all the classes. What happened to you earlier today? And good night to all others joining us in the chat, and those on YouTube, those on Facebook, those on Twitter, and wherever else in the known universe you are welcome. Thank you for joining us, and hopefully you can stay with us. let me share my screen now. Okay. So Dinsmore is saying he was busy. Okay, so we all have things to do. Thank you for taking the time to join us tonight. All right. Going to also welcome joining me in studio.
Good night, Miss.
Good night, Miss.
Welcome Iman and Dreshan.
Good night, Miss.
Good night. Welcome. So let's go on. This is easy stuff, scholars. This is really easy stuff, baby stuff. We're just doing this as a kind of, some preliminary, getting things out of the way kind of thing. We go to the heavy duty stuff. So the concept of factorizing, the root word, of course, factor. When we factorize, we remove or isolate the common factors. The word factor is a number or variable that can divide exactly into another term or variable. So for example, if I say 10, the number 10, the factors of 10 would be all the numbers that can go exactly into 10. So those would be 1, 2, 5, and 10. Those are the factors of 10. Suppose I say 16x squared. What are the factors of 16x squared? So we have an additional component. This time we have an x squared, which is a variable. So the factors of 16 by itself, just 16, would be 1, 2, 4, 8, and 16.
Excuse me, Miss.
And yes, Imani?
Are you writing it on the slideshow right now?
Not yet. No, I'm just
Okay.
yapping away. I'm just working my gums. So the factors of x squared would be what? What you say for that, Imani? What would be the factors of x squared?
Miss X or 1 and X.
1 is a factor. X is a factor. Anything else? Is there any other factor of x squared?
X squared. 1
X
X and X
squared. Okay,
Miss
x squared
X
itself, right? Okay.
Miss X
So that's the general idea when we say a factor. So when we factorize, we're given 2 or more terms, and we're going to look to see what number or variable is common to these terms. And actually, we want not just the common ones, but the highest common factor. So that's why our topic tonight is factorizing using the HCF, the highest common factor. So let's start with some really simple stuff. So for example, let's say we have 6x plus 4y. Let's say we have negative 5w in y. have 20x p plus 35x. All right, let's start with those. So we want to factorize these. So let me choose another color ink for the factorize. Let me choose red. So looking at the first expression here, 6x plus 4y. What is common to 6x and 4y? What are the common terms? The highest common factor.
2, miss.
Imani or Dreshan?
2, miss.
Plus 2.
So we know 2 can go into 6, 2 can go into 4, and it's actually the highest number that can go into both 6 and 4. In terms of the variables, the x and the y, is anything common?
No, miss.
No, miss.
No, because x can't go into y, y can't go into x. So we know that those variables are going to remain in the bracket. What goes in front of the bracket is the common term. So we said 2 is common, so we put on the outside, and then we open our brackets. What we're going to do, now that we have identified the highest common factor, we're going to divide each term by the highest common factor, and whatever we have left back, or the quotient, we're going to put that in the bracket. So 2 goes into 6x, 3x, right? And we put back our plus sign, and 2 goes into 4y, 2y, because 2 into 4 goes 2. Ta-da! That's it. We have factorized. That's as simple as it is. We just removed the highest common factor and use that to divide into each term and write the answer that's left back. So how about negative 5w minus 15y? What's common to those two?
Miss.
That's
Negative 5.
5.
Negative 5 is common, right? Because negative 5 can go into itself, and negative 5 can go into negative 15. So look what happens now. If I pull the negative 5 to the outside, what is left back? When I divide the negative 5w by negative 5,
It's W. It's W.
Yes, miss. W.
is it a positive w or a negative w?
Positive W, miss.
It's positive.
Positive w. Why is it positive?
Miss, because a
Negative.
negative divided by negative gives you positive.
It's positive.
Negative divided by negative give positive. Okay. So it's a positive w.
Mhm.
So we're going to put the w. And how about the negative 15y?
Miss, that would be positive 3y.
Why would it be a positive 3y?
Miss, because 15 is a negative number, and since we're dividing it by negative 5, it would be a positive 3y.
Okay, so whatever we put in the bracket, we should be able to use the distributive law and expand it back to get original thing. So if we have a negative 5 outside, we would need to multiply that by a positive 3y. We are to get back a negative y here. So let me show you what I mean. For this one, the 6x plus 4y, after we have factorized, we should be able to expand it, use distributive law, and get back the original thing. So if we have 2 times 3x, that gives us back the 6x. 2 times 2y, that gives us back the 4y. Likewise, we should be able to expand these terms here. So negative 5 times w gives us back the negative 5w. And negative 5 times positive 3y will give us back a negative 15y. Because remember, negative times negative is positive. Negative times positive is negative. All right, how about 20xp plus 35x? What's the highest common factor?
Miss 5x.
Question.
5x.
5x.
So the 6x, okay, so someone is asking me to go over the first one, the 6x plus 4y. All right, so we're factorizing, so we're thinking, what's the biggest number that can go into 6 and 4? And that number is 2. So we put the 2 on the outside. After we've done that, we're going to divide each of the terms by that 2. So 6x divided by 2 gives 3x, because 2 goes into 6 3 times, and there was nothing to work with the x, so we write back the x. And 2 goes into 4y, 2y. Understand? All right, so okay, so we're saying the highest common factor for the 20xp and the 35x is 5x. So you notice this time we have a variable out front, not just a letter, because if you common to both of them, x is common to both of the terms. So then if we 520 goes 4 times, and x cancels here, so all we're left with is p for the first term, and then 5 into 7 times, and x cancels the x. So this is what we're left with for the second term. All right, so how to see if you understand? If not, okay, so let me see in the chat if you understand so far. Just say, Miss, I understand. If not, let me know where we lost you so we can come back and get you. All right, so yeah. Okay, so far so good. So let's move on. Right, we're gonna split up a notch now, and this we're going to use 3 terms. So let me see, and I'm going to do this one vertically. I'm going to draw some lines separating them, right? Rather than horizontal. Okay. So let's say we have 2x plus 8y plus 10w. And we have negative 30p plus p squared plus 2p. And over here, let's say we have negative 3x minus 9x y plus x. All right, so let's see what we do with these now. Let's use another color. All right, so we have 2x plus 8y plus 10w. All right, Drayshawn, what's the highest common factor here?
So it would be 2.
How about the variables? Is any of the variables common?
No, miss. They're all different.
All right, so the variables are all different. X, we have a x here, we have a y here, we have a w here, so they are all different variables. So the only thing that's common is the 2, so we'll put the 2 out front. And it's the only thing that goes out front, everything in the bracket. So what we're going to do now is to divide each of the terms by 2. So 2x divided by 2 leaves x, and 8y divided by 2 leaves 4y, and 10w divided by 2 leaves 5w. I want you to do the next one for me. Walk me step by step.
Okay, miss. Number 2, negative 13p plus p squared plus 2p. Miss, so the highest common factor of the 3 terms is p. So we put p in front of the bracket.
P. Okay.
And p into negative 13p would give you negative 13 since they cancel the p.
Okay, so negative 13
Plus p into p squared is p since p times p gives you p squared. So if you take 1p from it, you get a p.
But let me ask you something though. Can we simplify this first?
Yes, miss.
All right. So tell me why I asked that. Tell me why I
Miss,
asked
to
if we
make
could
it
simplify.
simpler, to make the function simpler.
Because what? What did I notice there?
Because there's a p square.
Hmm?
That,
I noticed that we have a negative 13p and a 2p. So we have like terms here, right? All right, so
yes,
simplify
miss.
that for me first. Simplify that for me.
Okay, miss, I got my answer. So what I got was p squared minus 11p. Miss, how I got
All
that
right,
was
so we write
use
back our p squared. How did you get the minus p?
I grouped the two common terms, which by that I mean the ones that don't have a squared on them. So it would be negative
Okay.
13p plus 2p, which would give you a negative 11p.
Okay, so we combined the negative 13p and the 2p since they are both p, and we got
Yes.
negative. All right, so go ahead now and factorize.
Okay, miss. So the common factor is still p. So
All right, so the
put p
common
outside.
factor is and
So p into p squared goes p times,
uh-huh.
and p into negative 11p equals negative 11 times.
Okay.
And if we're supposed
All right.
to,
That's our.
okay.
Okay. All right, Drayshawn, I want you to walk me through the next one. So we're factorizing negative 3x minus 9xy plus. All right, let me make this so we don't run into the same issue again. Let me make this one x squared. Okay. So go ahead, Drayshawn.
So miss the HCF, this would be negative 3x. This was negative 3x.
Are you sure?
No, it's negative x. So negative x.
Negative x. Okay. All right. So negative x is the highest common factor there. Why not the 3x though?
It's
Can
because
3 go into 9?
3x, yes, was what 3 can't go into x squared.
Okay. So even though the 3 can go into negative 3 and it can go into negative 9, it can't go into, we have a coefficient of 1 here, which will leave a fraction of 1/3 if we try to factor out a 3, right? But we want to avoid using fractions when we're factorizing. We can if push comes to shove and we have to, but we like to leave our answers in an elegant form. So we want to avoid leaving fractions unless we can't go around that. So we cannot put a negative 3 out here, or we would have to put a 1/3 here. So what are we putting then? Negative x. That's the common
Yes,
factor. Right, so what's left in the bracket? Dreshawn, go ahead.
it wasn't making me unmute. So miss it would be 3.
So negative 3x divided by negative x leave 3.
3, positive 3. And then miss negative x into the negative 9xy. Miss it would cancel out the x. So miss it would be 9y.
So it would be 9y. Okay.
And miss negative x into the x squared. This would be x. Negative x.
Negative x. So why is this one negative and the other one was higher is positive?
Because it's like 2 negatives make a positive. So miss it would have to be negative x.
All right. So we have to bear in mind that when we expand it back using the distributive law, we should be able to get back the original thing. So negative x times 3 would give a negative 3x. Negative x times 9y would give a negative 9xy. This one now has to be negative because this one here is positive. Because negative x times negative x will give a positive x squared. All right, so those in the chat, shout out and let me see, understanding what we just did. That batch of 3 that we just did. Shout out, tell me you get it or you don't get it, or you almost get it. Give me some feedbacks in the chat. Move on and kind of step it up a notch. All right, so Dinsmore is congratulating scholars and he's saying nice job. Let me join him in nice job, Imani and Drayshawn. So far, so good. All right, so we're going to do some more. And I think next week we can go on to factorizing quadratics, right? Yeah. we can go on to factorizing our quadratic expressions. All right, so let me just separate my page, and I'm going to put 3 more. All right. I mentioned a while ago about fractions. Should I put some fractions? Maybe in the next round of fractions. So we have x, y plus w minus 10p. Okay, so we have that one. And we have 32 x to the 4th power minus 16 x to the 3rd power and y. And here we have 5 p squared q minus 20 p q. All right, here we go. Whose turn is it? Imani?
Yes.
All right, Imani, 6xy plus w minus 7p.
Yes, well, since there's no common factor.
Is that a true statement?
Well, one is the common
It's
factor.
1.
Okay.
Only 1.
So 1 is a universal factor. 1 is common to all numbers. Yeah, but the thing with 1 is, if we try to factorize using 1, what's going to happen?
Yes, we're going to get the
You're
same
going to
answer.
write back everything. You should get back the same thing.
You get back the same thing. So it doesn't make any sense, right? It doesn't make any sense to factorize using 1 because 1 is just going to go into the terms the same amount of times. Okay. So it's not really accurate to say they have no common factor. But it's just that 1 is the only common factor. So it's better if you say it that way, right? So what does that mean then? What do we do?
Miss, we can just
Let's
rewrite
put
the
1. I'm to write it.
equation.
Yeah. So I would recommend, rather than just leave it like that,
Put 1 outside the bracket.
don't put a 1.
Okay.
Remember, we just said that doesn't make sense to do. But rather than just leave it, I would recommend that you write it back. Just write it back just as it is, so that the exam knows that into the matter and you have made a decision that it cannot be factorized other than to use 1, right? To just leave it as is might indicate that you don't really know what to do with it. You understand? So rather than do that, I would recommend that you write it back. All right, Drayshawn, read the problem and then tell me what to do.
Plus 32x to the 4th power minus 16x cubed y. So miss x squared. Yeah. The HCF would be 8x squared.
Speak up, Drayshawn. What are you saying?
Oh yes, miss 16. Miss HCF
All
would be
right, so you're
16.
saying 16. 16 is the
16x.
highest. 16x what?
Miss squared.
Squared? You sure?
Miss 16x. Won't be in the 3. It's just 16x.
Huh? Not yet. What's the power of x outside here? What power of x do I have? Huh?
Miss, if we
You have
put
to
x,
speak up. You have to speak up in addressation. Is it just x? Is it x squared? Is it x cubed? Is it x to the fourth power? What's the power of the x in the
so Miss, wouldn't it just be Miss 16x squared?
No. Square isn't the highest power of x that can go into those terms. What you say, Imani?
Miss. Miss, if we had, if the two of them were x to the fourth power, we could have put x squared, but since they're not, we can't put x squared because x squared can't go into x to the three power without a remainder.
So what do we put out here?
Miss, x to the one power.
Are you sure? Look at it good. Is that the highest power of x that can go into x cubed and x to the fourth power? X cubed is the highest power of x.
What? Miss, it can go into x to the fourth power?
Yeah, leave back x. X cubed times x, isn't it x to the fourth power?
Oh, yeah.
Oh,
Remember the
okay.
laws of indices say
Yes, miss.
when we're multiplying and the base is the same, we add the powers.
Yes,
So
miss.
x cubed times x is x to the fourth power, right?
Yes, miss.
So x to the fourth power divided by x to the third power would leave x. So I think I know where you two, I think I know what your issue was. You're thinking in order for it to go into x to the fourth power, it would have to be like x squared, right?
Yes, miss.
No.
Because
We can
this
take
also,
3x's out of 4. So just like if you had x to the fifth power, x to the fourth power is a factor. You can take 4x's out of 5, right?
Yes, miss.
Remember, when you're dividing variables like that, what you're really doing is canceling them one for one. So we can take out 3x's out of 4. So 1 is left, and 16 into 32. So continue for moderation.
what do you say, Miss?
Continue. Tell me what to do now.
Oh, so Miss, first the 16x cubed. This would go into 32x to the fourth power. Miss 2 times leaving x only. This
So
would be 2x.
2x.
And then Miss minus, Miss minus y.
Okay, because it's
16x
16x cubed goes into itself, right?
times, yes, Miss. And there's a y.
All right. So
So it would be
Imani,
minus y.
yeah. Okay, Imani, read the next one and walk me through it, please.
Okay, miss. 5p squared q minus 20pq. Miss, so the common factor here is 5pq since the two terms have p and q. So
All right. So
it
5pq is common.
yes, miss.
Right. So when we take 5pq, when we divide that into 5p squared q, what is left?
Miss p.
Okay. P is left. And then
5 PQ into 20 PQ is into negative 20 PQ is negative 4.
right, because the PQ cancel the PQ. All right. Okay, so that's another batch. All right, so let me see how we're doing now in terms of time. So we're at 40 minutes. All right, so my scholars in the chat, what's going on? Dinsmore is asking what class these students are in. That's always a weird question for scholars because scholars are in all kinds of classes, no matter their age. Dinsmore is a really weird question for us because even babies start introducing them to advanced stuff, right? So our PEP scholars, they do CSEC work, and our CSEC scholars remedial work. So everybody is working on, they're working on their goal and they're working on advanced work as well as remedial work. So that's how we take it. We're in every grade, math included. Our in every grade. All right, so let's do another batch. I think we can do one more batch. Okay. So tell me, is there anything I'm leaving out in terms of, I want to make sure I include everything. Because remember, we said next week we're going on to the big guys, the quadratic. We're going to be factorizing our quadratic expressions. So let's make sure that we have everything covered. Is there anything I'm leaving out? Have we looked at where we have the negative numbers? All right, so okay, so let's see.
That was
I
going to
want
be
some
this
more.
rough.
Okay, so I want some more space. Okay. No, I don't draw straight lines. So, all right. So let's say we have a half xy squared minus 4x plus 5x squared. All right, and let's do another one. Let's say we have 3/4 p q squared plus quarter p to the third power and q to the fourth power. All right. Okay, so let's go. So Imani, you take the first one. How would we approach that? Read it for me.
Half xy squared minus 4x plus 5x cubed.
All right, so how are we going to approach that? Look at it carefully. How would we resume? How would we approach that? Or Drayshawn, if you have any ideas.
Miss
Unless we
to
use, unless we use half, unless we use half x.
All right, so if we use half x, all right, so we
Miss
put
to
half x out here.
oh no, we get to another.
What will be in here?
Miss y squared
Y squared
All right, so we have y.
minus
Okay,
2
2.
yes miss
If we need to get back 4 here, what would we have to multiply the half by? Half of what would give 4, in other words?
sorry
is 8.
8
This will be
8.
8.
Okay, so that would be 8. Just 8 because the x is
yes
there, right,
miss
already?
X is
All
yes
cancelled.
right.
miss
All right, how about the 5?
plus 10x
10 is 10x.
Okay, so that would be 10 and just 1x, right?
yes miss
Yes, miss.
yes
Okay,
miss
see, that wasn't so bad. That wasn't
yes
so
miss
bad, was it? Let's check back. So let's double check to see if when we multiply them, when we expand them using distributive law, if we would get back the original. Remember, this is how we check to ensure that we did. Okay. So if we expand this half x times y squared, that would give us back half xy squared, right?
yes
Half times negative 8 is negative 4 because 2 into 8 goes 4. And then we have back our x. Half of 10 is 5. And x times x would give us x squared. So we're good to go for that one as well. All right, Drayshawn, so your turn now. So look at that one. Examine it keenly.
Um, this would be it's a quarter p cubed.
Okay, so a quarter is common. P is common. And you're saying Q as well?
Yes, miss.
Just Q?
And miss
Is it just
squared.
P and just Q, or are there any powers involved?
Yes, miss squared.
All right, so Q, which one of them? P squared or Q squared?
Wait, miss, that's q. Wait,
Just Q?
miss both of them. Uh,
Make up your mind, young man.
uh, wait, miss p could go into the first. Miss p could go into 3/4 of p,
Okay,
and
so P, we know P is that this is the highest we can go because any P higher can't go into this one, right?
yes, miss.
So, but the Q now, this isn't the highest Q can go. This is Q squared, This is Q to the 4th power.
Yes,
So can't we
miss.
have a Q squared outside?
Yes, miss.
Yeah, it can go into Q squared and it can go into that. So that we have a Q squared. All right. So what would we need to multiply a quarter by to get 3/4?
Um, miss 3.
3, okay. And the P and the Q squared cancel each other. You see that? So we only have 3 here, okay? All right, so what do we do over here now?
Oh, miss, and then miss would be a quart. Wait. Oh, so miss, then it would be miss P squared Q squared.
So
Miss a
what we're doing with
quarter
the
to a
quarter?
miss would be
Hmm?
gone. It's a quarter into quarter.
So this quarter cancels this one, a quarter into
It
itself.
cancels the other
So
one.
that's gone. All right. So
Yes,
P
miss.
into P to the third power, leave backwards. What we have here, P to the what?
Miss, it would be P to the squared.
P squared, yeah.
Yes, miss.
And what about the Q?
And then miss, it would be Q squared as well.
Why would it be Q squared?
It's because 2 squared is into Q quarter.
Okay, so
That's
we're taking 2 Q's out of this one. All right, so we're left with Q squared. So let's now using distributive law to double check and make sure that we have back our 3/4 and the P Q squared times 1, because nothing else is here, would give us back that, right? And a quarter times 1 would give us back a quarter. P times P and Q squared times Q squared would give us Q to the power. All right, man, I want you to think and make sure that we're not leaving out anything involved in factorizing, but you're going to get, but if push come to shove, you have to, if you can find a common factor, I think that is not something that can be done. It can absolutely be done, just like we did it for the fractions. It can be done, just that you're not likely to see it. But don't be confused if you are given some factorizing and there are decimals involved or fractions involved. So I know I made sure to include negative numbers to show you that when you're pulling a negative out to the front, sometimes you have to change the sign of the terms on the inside in order to get back the original thing. Because remember, when you're factorizing, you are supposed to be able to expand law to get back the original thing. So sometimes if you pull a negative number to the front, you're going to end up having to change a negative sign so that when you multiply it back outside, you would get back a positive in the original. I made sure to include some of those, and also made sure powers to show you that you can pull out some powers and just add up, or you would have to be left in the inside the bracket. So guys, did we cover everything? The highest common factor. Hope we did. Yeah, I hope we did everything. So when we're doing algebra next Tuesday, we're going into the big leagues. We're playing with the big sharks, swimming with the big sharks next week, factorizing quadratic expressions. For us, it's just a walk in the park. Isn't that true, Imani and Dreshan? easy stuff for us, but we know that these are challenging things for many students. There are methods, there are shortcuts that you can use to factorize your quadratics. And we're even going to go a step further and to actually solve. So after we factorize, maybe the next class we'll do solving quadratic equations using the method of factorizing. So that's what we have planned for next week. So let me thank my in-studio crew for staying with me and for helping me to work out these problems. I did not acknowledge Amari, so let me do so now. Amari, welcome. Even though we're on our way out. Is it Amari or John? I can never tell sometimes.
Amari, miss.
Okay, it's Amari. All right. And to my scholars in the chat. Well, let me read. I'm seeing something in the chat here, guys. So somebody is saying, hold on. Where is it? Okay. Oh, so Dinsmore is saying, Miss, I believe when these students are finished with maths, they will be able to teach you. But of course, that's how it should be, right, guys? It should get to a point where the students start to teach the teacher. That's how it should be now. The master teaches, and then the student gets to a point where the student can now take over and even teach the master some things. There's nothing wrong with that. That's life. That's how it goes. And I always say, teach and you will learn. If you want to test, if you really know something, try teaching it to someone else. And from my experience with teaching, the more I teach, you're explaining something to someone else. You I'm just seeing this part also. Each other. My uncle always say, iron sharpeneth iron. We're all about on this channel in this school. So thank you, Dinsmore. You are our faithful, very, very faithful follower. Almost every day you are here, and we appreciate you. Thank you to the other persons in the chat. Thank you again, Imane, Dreshan, and Amari. I will see you, students, tomorrow. Take care of yourselves and have a good night. Get ready to go in the morning. Hello, CSEC math students. I know you are busy preparing for math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. The common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors, we can certainly avoid. Come on, take my hand.